Yes, sir.
Okay, thank you. Uh, okay, so dear students, actually today is the lab session. So still I didn't started labs because every day we are continuing with the instructions. Okay, so today again three category of instructions I want to cover. That is logical instructions, arithmetic instruction, and decimal adjusted instructions. So once we covered these three category of instructions, automatically we'll start with lab sessions on that. Okay, so not don't take that much risk on the lab because still this is also a online examination is going on for you also, but you have to more concentrate on theory part. And lab session I will take on Tuesday. I have to make it as lab session for you. Okay, so for your betterment of that, today for your lab session I have to continue with theory, and almost this instruction part I have to cover. So once we cover instruction part, it is helpful to do the lab programs. So for that, what
What?
just a minute. What is there with this? Yes, okay, today is good strength, not a problem. So okay, I will save my screen. That is unit number 3, right? Yeah. Okay. uh, See, in previous we saw many category of instructions. Like in the last we lecture, means yesterday, we saw this interrupt control instructions. Okay, that three types: int type, int o, and return. So today, is there any doubts from the previous instructions? All of you covered whatever, studied whatever I covered in the lecture. So please, if you have any doubts or any instruction is not understood, please let me know. I have to clear your doubts. Okay. So if not, again, I will start with uh, some string instructions today. Today string instructions we will start, and decimal adjust instructions we will start, and that instruction. So and also we will start with arithmetic instructions, and we'll start with decimal adjust instructions. These are the decimal adjust instructions, and after that we will start with logical instructions. So that logical today, once we know these many instructions like logical instructions, arithmetic and instructions, decimal adjust instructions, and string instructions, so then easily we have to go for the lab sessions. Okay, so come to this uh, string instructions. So in the string instructions, these are the category 3 plus 3 plus 3 plus 3. Totally 15 instructions are there in the string instructions. So just you name the instructions, explanations you will easily understand in the lab sessions. Okay, string instructions are used for the series bytes of stored sequentially, and the source string is at a location pointed by SI and data segments, and the destination string is at a location printed by uh, data index. It means destination index for the extra segments. So the count for string operations is always given by the C register, since from CX is a 16-bit register, and the source index and the destination index for the increment and decrement after each operations depending upon the direction flag. So if in that we have to check it as direction flag df is equal to 0 or df is 1. If df is 0, then we have to say auto increment with clear instruction, that clear direction instruction is used. If it is 1, then we have to use a string stored directions instructions in the auto decrement. So this today, these are the instructions comes under string instructions: move s, move b, move sw, loads sb, loads sw, and that stores b, stores w, like this. So today first one I have take it as move s. So in the move s means what? Move sb also we have to take, move sw also we have to take. The move in the sense move the string, you have to string data, you have to move it. So in this move string, what it will do, it is used to transfer you. Am I audible? My screen is visible to everyone, right?
Yes, sir.
Okay. So in the move string, uh, it is used to transfer a word or a byte from a data segment to extra segment. From the data segment to extra segment, we have to use this move instruction. And also for the offset of the source in the data segment, that is in the destination index di, and the offset of this destination in extra segment, that is in destination index again. So the destination index and source index you studied, destination index, source index in the architecture of 8086, right? So these are used for decremented and incremented depending upon the direction flag. Either direction is 0 or direction is 1 for the auto increment in the clear direction and store directions. Okay. So for example, in the move SB, in the move S is a common, and move SB is a move SB1 and move SW. B in the sense what here is a byte, that is a byte transfer, and W here in the sense what, that is a word transfer. Moves either byte or move either word. So here in the extra segment, that is a destination index. So whatever contained the source index, that is transported into a destination segment, data segments. So yes, extra segments. Depending upon that direction flag, either it is 0 or 1. Same way in the move S, it is related to W, means word, that depending upon this the word in the sense what, again extra segments from the destination index plus 1, which is transported into extra segments. Okay, that is SI plus 2 is in the plus 2 is for word, because more data is storage, and for plus 1 is byte, either it may be plus or minus 1. So that is for the move string. Okay, move mov, it is a move, yes means string, with the move string with byte, move string with word. So next one, that is a loads in the sense what, to load the string. If you want to load the string on a particular register, that time we have to use load s. That is again load sb in the sense what, load string byte or load string word, load string byte or load string word. So it is a also used to load a byte or a word to the accumulator or AX register from the data segment, and the offset of the source in the segment is in source index. So the source index is incremented or decremented depending upon our instruction as per the direction flag. Okay. For that, loading the data on the string or the byte in a accumulator or a register, we have to use this load string. For example, here loads b load string byte, that is source index to the data segment which is in the accumulator, a in the sense accumulator, and that plus or minus 1 with stored in the source index. Same here with the byte, plus or minus 2 depending upon the direction flag, df in the sense what, that is a direction flag. So next, the third category, STOS. It is a store string. STOS means what? To store string, either a store string byte or a store string W. So it is used to store accumulator or AX into the byte or a word in the extra segment. So the offset of this destination in the extra segment is, that is destination index, and which is used for increment and decrement depending upon the direction flag, same way. So here the stores string byte, that is with the accumulator transferred to a destination index to the extra segment with plus or minus 1 because of this byte is there, and with the word that should be becomes a plus or minus 2. That accumulator with a 16 bit, that is transferred it into extra segment through the destination index to ES, that is extra segment. And this destination index, which is to be formed by destination index either plus or minus 2 bits. Okay, that is depending upon the direction flag. So this is the category third. So here first one is a moves category, second one is a loads category, third one is stores byte and word, loads byte and word, moves byte and word. So now CMPS means what? Compare string with a byte or compare string with the word. And next one is scan string with a byte, scan string with a word. So move S is over, loads is over, stores is over. Now I'll start with compare S, that is compare string. Fourth one is compare string. Clearly I have to give on the notes. So here in this compare string byte or compare string word, so it is used to compare a byte or a word in the data segment, that is going to be compare between the two bytes or compare between the two words in the data segment with a byte or a word in the extra segment also. So the offset of this byte or a word in the data segment is in source index. The offset of this byte or a word displacement in the destination index. Okay. So the source and destination index again automatically incremented or decremented depending upon the direction flag. So that comparison is done with the subtracting or maybe a addition or maybe multiplication, whatever the arithmetical operations you have to do with the comparison. So that flag is also affected, but the result is stored in the finally destination index. Okay. So here the example, compare string byte and compare string word. So the compare string byte, that is with the plus or minus 1, that is a destination index to destination index, and compare string word plus or minus 2 with the destination index. Okay. So this is compare, just it is going to be compare with the two string. Okay. This much portion you have to cut it. It is the repetition of the second example. So this example you have to follow for the comparison string bytes and the comparing string words. Then the last category that is SCAS means scan string. It is nothing but what? It is a scan string. So the scan string with the bytes or the scan string with the word. So it is used to compare the contents of AL register or AX with a higher bit 16 bit with the byte of word or a byte, and the extra segment is going to be stored in that. So here the offset of this byte or a word in the extra segment is in DI, means destination index, and that destination index may be incremented or decremented depending upon the direction flag. Okay. So Again, here in the example for the comparison done by subtracting all a byte with a word from the extra segment, that is accumulator, with the flag bits on the offered, but the result is again stored in anywhere of the memory. So here, for example, the scan string byte, that is compared AL register means accumulator with the extra segment by using the destination index. Clearly how to mention here. And in the destination index, that is destination index plus or minus 1 depending upon the directions flag. Same way with the word. So whenever the word is comes, it's a 16 bit, and whenever the byte is comes, it's a 8 bit. One byte is equal to 8 bit, one word is equal to 16 bit. Okay, so just you have to go through this. And one more extra it will comes, that is a repeat prefix with the string instructions. So whenever that repeat is comes, that is used for the string instructions only, and it causes the instruction to the repeated CX number of times. CX means what? 16-bit C register. After each execution, the source index and destination index registers are again incremented or decremented based on the direction flag. So the CX register, 16-bit C register, must be initialized to count value. So move CX, that is 0023H, that code, and the repetition of move string. This is the one example of repetition string. Repetition means same string going to be repeated. That's what each time I have to mention plus 1 minus 1. The SI DI with the plus 1 and CX register with the minus 1 to be executed for 23s times of auto incrementing mode. Okay, so next, repetition on 0 and repetition on equal. Either the repetition is not happened means 0. If same all string is going to be repeated, that is repetition of equal. So in this condition, the conditional repeat instruction prefix, and it behaves the same as a repetition instruction provided the 0 flag set, that is ZF equal to 1. So it is used with that comparison instructions. And same way, that repetition 0 and equal. Next is repetition non-zero and non-equal, that repeat on non-zero and non-equal. So it is conditional repeat instruction prefix, and it behaves same as a repetition instruction provided in the 0 flag. So again, we have to set it into ZF is equal to 0, because that non-zero and non-equal is depends upon 0 flag. Is it 0 or is it 1? And if it is 1, then it is going to be scans. That is scan string instructions should be carried out. Okay, so these all are string instructions. Just every explanation is same. All are same. Just only you have to use that move s means move string with the byte or the word. So that is data is transferred from one to another, means source to the destination. Same way in the loads means load string with the byte and with the word, that is loads the string from one register to another register. Same way store the string from one to another, compares the string between two registers, and scans a string between a number of registers. Scan means what? Just it is going to be reading the data from that registers. So all these just difference is same, but only the difference it is 1 or 2 lines. Okay, so this is all about string instructions used in 8086. So next I will move to the category of there is a one string instruction format I have to mention with 1 byte, 1 byte, 1 byte, 1 byte, and 1 byte. Totally how many? 1 plus 1, 2, 3, 4, 5, 6 bytes. Okay, entire that string instruction is looks into the 6 bytes. Totally 6 bits of 6 bytes. Okay, so this one upcode is there, addressive mode is there. Just register, you have to go through it. So just for the format of this string, nothing is used for this, just I have to make it as extra. So next, after the string instructions, I will move to arithmetic instructions. After the string instructions, we will move to arithmetic instructions. So in the arithmetic instructions, we have to study add instruction, subtract instruction, increment instruction. So add or add C means just normal addition or addition with carry. ADC means addition with carry, and SUB means subtraction, subtraction with borrow. SBB in the sense subtraction with borrow, and increment and decrement instructions. And next operations, multiplication, implicit multiplication, and division, implicit division. Okay, so this is negative means non division, non multiplication. So again, some instruction, CMP means compare, compare with a byte and word, compare with word and data. So here decimal adjust, all are comes. Okay, so decimal adjust we will see in the later. First we will see that arithmetic instructions. So in the arithmetic instructions, that first one I have to take ADD or ADC. So ADD means what? Normal addition, and ADC means what? Addition with the carry. So here the addition the source to the destination, and result stores result back into the destination register. Very important point is here. First one, the addition of source and the destination, or source to the destination, and it the result is stores in the destination. Very important. So the source register, memory location, immediate number of destination register, and both the source and the destination have to be of same size. That is, the addition also adds the carry into the result, that is add C. So here add AL25H, it means that the 25H is going to be add with whatever the value of accumulator. So the 25H plus AL is equal to accumulator value stored in the destination point. Same way BLCL, BL and CL values are stored, added and stored it into the BL register. Same way in the BX register. So here I have to use add carry. Whatever the CX register and BX register values are there, that is going to be added. If carry is comes, that is also stored it into the BX register. Okay. And next one is subtract or subtract with borrow. Normal subtract or subtract with borrow, that is the destination source. So it subtract the source from the destination and stores results back into the destination. So the source register, memory location, and immediate number of destination register. Same way in the addition. Here you have to use add, here you have to use sub, here you have to use add C, here you have to use SBB, subtraction with the borrow. So here in the subtraction, AL25H means what? 25 is you are going to be minus with AL register, and this result is stored in the AS. That is the meaning of AL minus 25, and this result whatever comes, that is stored in the accumulator of destination. Same way in all the example, but in last one with the borrow, that is should be stored in the SBB. So here with the carry flag means what? Borrow. That CX minus BX, whatever carries comes, that one also goes to be stored in the BX register of destination. So next one is the increment destination. So increment means what? Every time it is going to be incremented by 1 in each iteration, or we have to say in each cycle, that if increment INC BX in the sense what? The BX register value is going to be incremented by 1. How many times we have to take that increment? So those many increments should be happened in this instruction. So for that we are using increment, and only we need destination to the one register, that is a destination register. It may be incremented by a normal register, or a word, or a pointer. BX means what? Address of the BX and address of the BL also we have to increment it. We have to increment it with the particular value of the register, or we have to increment it the address of the particular value of register. Address also we are going to be incremented, and value also we are going to be incremented. Same way we have to do with the decremented with the destination. So in this, it subtracts one from the specified destination, and the destination is the memory location. So here D is bx means what? The value of bx register is going to be decremented by 1 each time. Either it may be a pointer or address level or a register level or 8 bit or 16-bit level. Okay, so that is going to be decremented by 1 in each iteration. That is decremented destination. Okay, so in the fifth category of the arithmetic, that is multiplication. So unsigned multiplication, either 8-bit or 16-bit register. Actually, these are comes the your lab session is started with these programs only: arithmetic addition, subtraction, and arithmetic multiplication, arithmetic division. So in the first lab session, we have to do these programs only in the execution in the lab sessions. So in the multiplications, to do the multiplications again, source is need. So that is mulbl means what? The BL register is going to be multiplied with the accumulator and stored it into AX register. Same way, the BX is multiplied with AX and stored in the AX register, that is with the DX register. Okay, this is the multiplication. We have to use the instruction MUL for the multiplication. Next is IMUL. Source means what? The signed bit register, that the signed bit register of 8 bit 16-bit multiplication. So here we have to use a signed number. IML means signed number. Normal mul means only unsigned number. We have to use it. So again, division source unsigned and division source signed. We have to use it for the division purpose. Signed and unsigned, all these programs we have to do in the next lab session. Okay, so for that only still I didn't started any lab sessions. Once you come to know the idea about where we have to use it for div means division, IDIV means signed division, IML means signed multiplication, ML means signed multiplication, ADD means add addition, ADC means addition with carry, and SUB means subtraction, and SBB means subtraction with borrow. Like this we have to use it. So in the division also, that is division BL, that is AX is divided by BX, and that finally stored it into the accumulator quoted with a reminder, and that BX division is also quoted, so that is reminders. Okay, so the last one is NEZ destination. So NEZ is there again, that is okay, 3 more are there. So NEZ means what? It's a negative, means two's complement negotiation. That is means the two's complement. So in this instruction, the forms two's complement of the destination, and it stores it back into the destination. So here the destination register memory locations are the main part of NEZ instruction. And for example, if assume AL is equal to this much value, that is 35H, 4-bit each other. You first 4 bits are 3 and next 4 bits are 5. Then the negotiation is equal to 1000. That is negotiation of means what? It is a 2's complement. 2's complement means 0 means 1, 1 means 0. That is going to be formed it here. And again, the CMP destination, and so this is the comparison of two values. That is the instruction compares the source with the destination. Source and destination must be of the same size. So the comparison is done by the internals, that is subtracting source from the destination. So here the subtracting is not stored anywhere instead of flags only affected, and all the condition flags are updated by using the source register memory location. So the memory location and the immediate value destination registers are, it should be on the memory location, and all condition flags is going to be updated automatically by using this comparison, means comparing the two values of source and destination. So next one is CBW. It means what? It's convert signed byte to signed word. Converts byte to word. Next is converts word to byte. Word to data. Here or byte. So here sometimes we need a conversion during the operations, byte to word and word to byte. And also here sometimes we have to convert word to double word. D means what? Double word. Word to double word. So the convert signed word to signed double word. So in the conversion of byte to word for the manipulation of data, this instruction copies of sign of the byte in the accumulator and throw it into the AH register, and no flags are get affected for this conversion. So AX is equal to this much value, then it is automatically converts it into byte of, means this of AX and AL value. So if we have to convert again byte to double byte, that time also we have to copy sign of the words, and that is going to be all bits of AX register. That is, this is the word and this is the double word conversion. Okay. So this is all about the arithmetic operations. These are not necessary only in the arithmetic operations. You first four you have to study it. That is addition, subtraction, multiplication and division with increment and decrement. That is more than enough. These are extra I given to you for your information purpose. Okay. So this is all about the arithmetic operations, and previous all are, that is uh, string instructions. So string instructions and arithmetic instructions. So dear students, what we will do again, remaining decimal addressed instructions are there, and logical instructions are there. Again, I will take half an hour. I will talk half an hour on this. So again, what you will do, notes is with you anyhow. So for this 10 minutes up to 2 o'clock, you have to go through all these instructions. 12 instructions I covered in arithmetic instructions, and 15 instructions I covered in string instructions. 15 plus 12 today, that is 27 instructions. Please, you have to scan. Okay. So please go through this 10 minute. Again at exactly 2 o'clock, I will start with this decimal addressed instructions and logical instructions. Just for half an hour is needs, we will cover it. Okay. Please read it well. Whatever this 15 plus 12 instructions I covered now, just you have to start study. Okay. Yeah. So uh okay, read. Any doubts? So very easy. All, yeah, yeah, just the name itself, it shows the name, that functioning of the instructions. Okay, so no difficulties in that. Just actually, they in the textbook and all, they have to mention list, but for that you will better understand purpose, I have to made it all the explanation. Okay, so just you name all the instructions also more than enough. So again you take 5 minutes to read it out. Yes, again come to the lecture. So again you will go through it later, okay, in your study time. So that's fine. uh yes, so again once we completed that string instructions and that arithmetic instructions, now I will move upon decimal adjust instruction, DAA, that is decimal adjust instruction. After that we will go for logical instructions. So only these two topics are remaining in the unit number third, that decimal adjust instructions and logical instructions. So here first one, that is decimal adjust instructions for the addition purpose. Decimal adjust addition, DAA, in the sense what? Decimal adjust addition. So in this, we are going to make the result by using BCD form after BCD addition of to be performed, and it works only on AL register. So all flags are updated with the overflow becomes undefined after this instruction. So here, for example, if there is a 001 and 0110 and the addition with this number, we are going to do the adjustment addition with this 0110, that is the value of 7, that is the value of 6, sorry, 6 with the 0110. So with this addition, adjusting with the addition to getting the correct output of these two numbers, that is decimal adjust. So it becomes a 4 plus 2, that's the exact answer of these two addition of numbers. So for that we are going to use decimal adjust for addition, and decimal adjust for subtraction. Same way, in the two numbers, it makes the result in packed BCD form. That is BCD subtraction is performed. So and it works only in the accumulator register, and all flags are updated for overflow becomes and undefined after these instructions. So for example, if this is a 1000 and 0110, here we are going to do the subtraction, so that AL is 86H, this is 86, and CL is 57, this is 5, this is 7, this is 8, and this is 6, 86 and 57. We have to do this subtraction, This one we have to getting, but this is not a correct output. 2FH. Our correct output is 29. We have to getting 86 minus 57 is 29. We are getting. So we have to do the adjustment, decimal adjustment, that is with the 6 value. So we will get it 29. Okay, that is the correct value. So this is the uh, decimal adjust subtraction. Next one is triple A. It means that ASCII adjust for addition. ASCII adjust for addition. So it makes the result in the unpacked BCD form, and this is going to be ASCII codes of 0 to 9 are represented as 30 to 39. So when we add this ASCII codes, we need to mask the higher byte, that is example of 30 to 39, higher mask values. So this can be avoided. This triple A ASCII adjusted addition can be avoided if we use the instruction up to the addition formation. Okay. So for example, consider AL is this much value 0011 and 0111. That ASCII is the 4, and for this value the ASCII is the 8. So this is 4 value means ASCII is 4, and this is the 1000 means ASCII is 8. So then we have to add the accumulator with the CL gives 0110 and 1100 with the 6CH, that is incorrect result. So for that we are going to use the ASCII value of 000010, that is unpacked BCD 0 values. So with the carry has 1 indicates 12 as an answer. Okay. So here the ASCII adjust for subtraction. The ASCII adjust for subtraction. AAS. AAA means ASCII adjust for addition. This one, and this is for ASCII addition. uh, the ASCII adjust for subtraction. Same way, consider AL is this much value, and that is 1001 is a 9, and CL is this much value, that is with the ASCII of 5. So subtraction of AL with the CL gives this 4 value, that is 9 minus 5 is 4. But now AAS with the ASCII adjustment subtraction, that is 40 with the 010 unpacked BCD form of 4, and the carry is going to be 0 values. Just we have to use these calculations for the scientific calculator, and you will get it this answer. Okay. So the next one is AAM BCD adjust after multiplication. Adjust after multiplication. Once multiplication is over, we have to adjust the bits, that is for multiply two ASCII digits, we mask their upper bits, and this we have to unpacked BCD operands, and after two unpacked BCD operands are multiplied, the AAM means adjust after multiplication instruction converts this result into the unpacked BCD form in the AX register. So for example, AL is the this much value, that is 0 with 1001 means 9 value, that is unpacked of BCD 9, and CL is this much value with 400 0101, that is unpacked of BCD 5. So here then the multiplication CL gives AX with 00010, that is 002D H values. Okay. So this is your adjust after multiplication. Next, adjust after division. Binary adjust after division. So this instruction converts the unpacked BCD digits into accumulator AL into a packed BCD in accumulator. Binary code digit. BCD means what? That is binary code digit in the accumulator. So this after adjust with the division, that updates parity flag, sign flag, and 0 flag. So with this consideration, CL may be a 07 value, and AH may be a 4 value, AL may be 3H value, then AX becomes a 430H 0403H value. So 04 and 03. BAL means what? Lower nibble. AH means higher nibble of 04. And this addition of these two is 07. So lower nibble 03 and the higher nibble 04. Totally the unpacked BCD value is 43 in the decimal what we are getting. Okay, same here for the division with the CL register, that quotient is to be happened with the unpacked BCD, division and multiplication, this division purpose. Okay, so next one, uh, we will move to the last instructions, that is logical instructions. So up to now we studied four instructions: AAD, uh, ASCII adjust decimal, ASCII adjust divide, and AAM, ASCII adjust for multiplication, AAS, ASCII adjust for subtraction, AAA means ASCII adjust for addition. So arithmetic instructions are only four instructions. Sorry, ASCII adjust instructions are four instructions. So the last one, that is logical instructions. So this logical instructions we completed. Then we have to close with the unit number third. Only the instructions in there in the unit number third. Okay. So in the logical instructions we have to study it: not, and, or, XOR, test. Five instructions we are going to be studied in the logical instructions, or we have to say bit manipulation instructions with an example. Bit manipulation instructions with an example. So the not destination in this instruction forms its one's complement of the destination and stored its back in the destination. The number of flags are get affected in the destination. So the register memory location, that is X and Y. How the not is formed? It is if 0 means you will get it 1. If 1 means you will get it 0. High means low and low means high in the not gate, right? That is a logical gate. So same way, if 0011 and 0101 is there, the opposite of this symbol is 1100 and 1010. That is the not operations. So and the on and operations, how the truth table is formed for the and operation: if any one of the input is low, then output is low, otherwise output is high. Okay, so in this instruction, logically NAND, the source with the destination and stores result in the destination. So the source and destinations have to be of the same size, and source register memory location immediate value. So the destination register memory location, and AL equal to 0011. So CL is 0101. So that AL and CL becomes a AL and with CL. AL and with CL. Same here with the R logical operations, that is destination with the source. So here this is the truth table for the R. If any one input is high, then output is high. Otherwise, the output is becomes a 0. That is a OR operation. So in that, the instruction logically asks the source with the destination, and the result is stored in the destination. So the source and the destination have to be of the same size. So the source, that is register memory location and immediate values with the destination register and memory locations. Okay, this is the OR logical operations. Next become a XOR. In the XOR, what is the truth table? If any one of the input is different, it means that any one of the input is other than the other input. If it is 0 means 1, if it is 1 means 0, then we have to say high. Otherwise, if the both the input are same, then we will got the 0 output. That is the X or destination source. So here in this instruction, the logically XOR the source with the destination and stores in the result in destination again. For the source, the register, the memory location, immediate value destination, and the register memory locations all are stored in the source. So this is a truth table line that BL and CL will manipulate with the XOR BL and CL. Then these two values we will get it here. Okay. So the last instruction, that is test destination with source, test instruction in the logical operations. So in this instruction, the logically finds the source and the destination, but the result is not stored anywhere. But the result is not stored anywhere. Only the flag bits are affected. So the source register, memory location, the immediate value, and the destination with the register and memory location. So these are the test destination and the source. Okay, so this is for example, if test BL and CL, that is going to be tested either BL and CL, so the flags are get affected, all the flags are get affected here. For example, BL with this value and CL with this value, so test BL and CL, that is with the AND formed between BL and CL, so the answer is become this one. Okay, so all flags are get affected means parity flag, zero flag, sign flag, carry flag, auxiliary carry flag, and overflow flag. All flags are get affected in the test uh, logical instructions. Okay, so dear all students, this is all about the third unit. So by today, I have to cover whatever the instructions are comes under this microprocessor. So please, all of you go through this. If you are perfect, if all these instructions you are remembered, then the lab session becomes very, very easy for you. So for that, what I will do after completion of this, today I will give you one software. Actually, today is a lab session. So I'll give you one software, that is TOSM, and this entire microprocessor programs you are going to execute on TOSM software or MASM software. Anyone you can use. Okay, either TOSM or MASM, and some other outsourced softwares also there to execute the microprocessor program. Based on that, you have to do it. So I'll stop it here for theory. Means third unit I have to complete it by today. And see, all of you come to this group, our DSY microprocessor group. This group, no, our personal group, that is microprocessor DSY microprocessor. Okay, this group. So here I will transfer that TOSM software. TOSM software. Just 1 second. Search where it is that. So I'll give you the TOSM software, and you have to store that TOSM software in your machine, and it is helpful for. Okay, here the TOSM software is there. I'll send to you. Yes. Here, desktop. See, come to the microprocessor group, DSY microprocessor group, microprocessor DSY 21. So here I transferred the one software, that is TOSM software. Okay, so this software is used for all types of Windows. Any types of Windows you have to install with this TOSM software. After installing, I'll give you the some commands. So those commands we have to use. Okay, so dear all students, just you download this from the group, and you have to install in your machine. All of you here, 15 students are present, but only 3 are views. Hello, yes, all of you are there here. Please.
Yes, sir.
Okay, okay. So I transferred in the group, that is TOSM software. Okay, so this software more user friendly for execution of microprocessor program. So what you will do, you have to download this by this WhatsApp group, and you have to install. You have to install in your machine. Okay, so I'll show you how to install. Just you have to double click on that TOSM software. It says okay, okay, okay. Click on okay, okay. Next, next. It will going to be installed in your machine. And through this software, we have to start lab sessions. So the addition of two numbers, subtraction of two numbers, whatever we have to studied, all the instructions comes under third unit. All along with all the instructions, we have to play the practical session. Okay, so here today what you will do, you go and install this software. TOSM 1.4 for Windows. Any Windows you can install. It is too much user friendly. Okay. So I will show you here on the desktop. You have to come. So this is the TOSM software. It's there no on the icon. See, I'll put it at the here. So this is the TOSM software icon. There is a one Apple symbol, and just you have to after installation, it will comes under on the desktop. So icon is that logo is TOSM 1.4 Apple symbol. Okay. So what you will do, you just double click on that. I am double clicking. So it is opening now. Okay. So this window is opening. That is a DOS prompt. This DOS prompt is opening. Along with that, there is a one more editable command window is also opening. So that is a DOS. Yes. This is the window is opening. So 4 commands I will give you. 4 commands I will give you for that. So those 4 commands also I have to given to you, and just a minute. There is a one word file. Yeah, just for the namesake here. Okay, fine. That's a file should be there. See again, the 4 commands I will send to you. So these 4 commands we have to use for the TOSM software. So remember this. The first one is edit file name.asm. By this command, we have to open the editable window, that is typing program window. And the second command, that is file name.asm, which is the TOSM. That TOSM file name we are going to be find it either any errors or warnings. Okay. And in the third command, that is t-link with file name.obj. T-link file name.obj. That objective file we are going to be connected with TOSM link. T-link means what? TOSM link, the file name with the objectives. And the last command we are using td file name.exe. It means that TOSM debugger, with the file name. Exe means what? It's an executable file. So by using these 4 commands, we have to run the TOSM software with any microprocessor program. So just one program I will show you by using how to use this command. How to use this command in the TOSM software. So today only you have to install this TOSM software. Just 1 or 2 minute time to need installation. Okay. And you keep on practicing by using these 4 commands. One demo I will give you. So what is the first command? Edit file name.asm. So here, this is the command window, that is give here edit file name. So file name means one of the file I have to given here. That file is already I have to created. For your demo purpose, I have to use bt block transfer dot asm. So this is one file. So give the edit. Bt means what? This is the name of the file. So block transfer one program is there. That's what I have to keep bt asm. Just you have to check with first command, that is edit bt.asm. Okay, file name.asm. So you have to press enter. This window is opening. So in this window, that program is there. These are the program for your microprocessor. By using this first command, this file is going to be opened. After that, you have to type this program. by using the keyboard. So this program I have to give you. This kind of program you have to type. After typing this program, you just go to file and save the file. Go to file and save the file, and finally in the file you come out from that. Exit can I click? So this is the exit, that is for first command. For that, while going to compile this program, next you have to give the second command. What is second command? Tasm tasm, that is file name. What is our file name? Name of the file is bt block transfer dot asm. This is our second command. So by using the second command, we are going to compile it. Okay. So if I have to press enter, it will shows here. It will shows no errors and no warnings. Warnings are none, errors are none. So for that, our second command uses for compilation. Again, after this warning sign messages are 0, then we will move to TASM link with the objective file. That's what we have to use. T-link with the name of the file bt dot obj. This is the third command. That is the third command. So this command is going to be link with the TASM software with all the objectives. Okay. So again press it. After this third command, you will get it, the version of this particular software, and no stack. No stack means your program is going to be started for the execution. So after this window you are getting, you have to use last command. The last command is td. Td means what? TASM debugger. td with the file name of the file is in our case bt.exe, that is executable file. So TASM debugger with the block transfer with exe, executable of file. So just you have to press this, enter this, again you will get the output window. So here all four, that is, so all four commands we have to use it in this all four commands, right? So this is the last command, td bt.exe. Td file name, bt is nothing but file name.exe. So press the enter, output window is opening. So in this output window we have to see the data. So the no symbol, just click on OK. So this is the output window. So like this we have to execute the programs in the software. So today I have to provide you the software. Please all of you go and install in your machine, maybe computer, desktop, laptop, whatever it may be, and be ready for next class to do the lab session. Okay. So once you come to know all the instructions of third unit and architecture of 8086, architecture of 8085, we have to start the lab session now onwards. In the next lecture, uh, half of the part I will take theory class and half of the part I will take lab sessions, every lectures, because up to now I didn't started lab session, right? So along with the theory part, parallelly we have to cover lab programs also now onwards. So all of you please be remember, we are teach in such a way that half of the part theory and half of the part lab in every sessions, and we have to cover parallelly theory part as well as lab parts. Okay. So this is the information for your today's lecture. By today's lecture I have to completed third module, and also I given you a brief idea about TASM software. You may not fit with the TASM software, but once we start with the program, that time I will teach you how you are become a fit with TASM software. Okay. So I'll stop it here. Please, any questions, let me ask. You go and practice this TASM software, installed it, how it is going to be, use all four commands. Okay. So let them ask any questions, please.
सर आमच्याकडे लॅपटॉप पण नाही आहे, पीसी पण नाही आहे सर. कसं करायचं आम्ही?
कॉलेज को आओ. क्या करेंगे फिर, ऐसा बोले तो क्या करेंगे? आप ही बताना है मैडम. So in this,
Sir, there is also Android application, sir.
yeah, there's a one Android application is there with the mobile. Madam, you have mobile, right? Android mobile.
Yes sir.
Yeah, I'll tell you one more option is there, but that is not user friendly or not that much means it's okay. Anyway, if there's no option, then that time we have to use it. I will tell you that how to use the Android with the mobile application. But my suggestion, all of you being a CSC background student, computer science people, so you must and should keep one laptop or one desktop with you. So it is not only a problem of this microprocessor. Everywhere, any subjects you have to learn, almost those subjects are related with computer only. Okay, if you may escape by using the Android mobile application for this subject, then what you will do for other subjects, like Python is there, like data structure is there. So I mean, minimum in a semester 3 to 4 subjects are computer related subjects only, and every 3 to 4 subjects are having a labs. So after suffered, so for example, if this semesters you may continue without the laptop or without the computer, and even next semester also. But one day you must and should you have to take the computer. The situation is comes in such a way that you must and should have a one computer or one laptop or any one machine with you. So for that, my side, it's suggestion, personal suggestion to all of you. Please, you have to keep one computer with you. Better. If you are CS background, there is no chance to without computer you getting a good knowledge here. And everywhere, if it is a offline, so computers are available in the college. Every labs computers are available. We are provide you, but in the online courses, we are helpless if you don't have a computer. So through the mobile, each and everything is learned. Is that is not a easy and it is not a comfortable. Okay, so hardly your mobile, all of you are using 16 GB, 64 GB, maximum 128 GB mobiles you have to using. But all the softwares needful degree learning needful softwares, it takes one more than 1 TB machines it needs, so that your mobile is not sufficient. So it is my personal suggestion to you, better all of you have to purchase. If you are not in that situation, because of you also facing the COVID, and every parents, every family members, they also facing COVID, and there's a money matter. Lot of people are suffering from the money as the expenditure, lot of expenditure for the education and all. In that situation also you have to use mobile. If nothing is option is there. Okay, so this is my small suggestion, don't take it as a bad. So by hook or crook, better you have to keep one computer with you. It is for your betterment, what I say. Otherwise, we have one on another option, we have to search that option and we will go through it. So okay, so if you don't have a computer also, don't worry, I'll give you one another option. That one you have to follow it with the Android applications. Yes, is there any other questions to me? Any other students have any other questions? Uh, Otherwise, can I stop it here?
Yes, sir.
Okay. Please, what you will do in the third unit, so many instructions I taught with a different category instructions. In the clearly notes I have to mention, all of you have to make a one list out, and that list you have to prepare 1 or 2 pages. Just only type of the category, under category what are the instruction names, like that you have to prepare one list. And that list paper, it may be a 2 page or 3 page maximum. So that those 2 or 3 pages always keep in your pocket. Wherever you have to free, wherever you are, some other places like outside home, outside your study room, or anywhere, so that time just you have to take from your pocket and you just remember all the instructions. Okay, this is one thing all of you follow. all 15 students. Today only take 3 or 4 pages, write it first category of the instruction, data instructions, next program execution instructions, string instructions, decimal adjust instructions, arithmetic instructions, logical instructions. Like that, you have to put the heading under the data transfer instructions. What are the instructions or comes? You have to make it as a list out. So like that, all the category instructions you have to list out in a 2 or 3 pages, and those pages always you keep in your pocket. Whenever you have a time and whenever you have a free, just you have to scan once or twice. Again, automatically all the instructions you should be keep in your mind. Okay, so this is the one better way for remembering all the instructions. And in next lecture onwards, what I have to say, lecture as well as lab parallelly we have to study it. Okay, thank you one and all. I have to stop with my lecture today. Thank you all.